Hello. Hello. Hello, dear students. This is your Engineering Mathematics 3 lecture. Last lecture, we have discussed case 3 and case 4 of shortcut method. Shortcut method is used to find the particular integral, the remaining half solution of LD, linear differential equation with constant coefficients. Now we are going to discuss here case 5 or type 5, when the function is f of x is equal to e raised to x into v. There is product of two functions. One of them is exponential and the second function v is any function of x. Then in that case, how to find the pi? Now the formula to find the pi is equal to 1 upon phi of d into f of x. Now here the function f of x is e raised to x into v. So put f of x is equal to e raised to x into v. Now how to find the pi for this product of two functions e raised to x into v? You solve first for exponential function. Now how to solve for exponential function? You replace the term of d. Replace the term of d by d plus a of phi of d. In phi of d, you replace the term of d by d plus a. You simplify that term and then you solve for v. See the next step. Replace d of phi of d by d plus a. Then you simplify the term phi of d plus a. And after simplification, you solve for v. V is any function of x. After replacing d by d plus a, the work of exponential function is over here. So you write down this exponential function as it is, e raised to x, and then you solve for v. Now you see the example. Example is here. Solve d plus 1 into y is equal to e raised to 2x into x. Here it is the reduced form of LD. Phi of d into y is equal to f of x. Now phi of d is equal to d plus 1, equate it equal to 0. So the auxiliary equation is here, d plus 1 is equal to 0. So d plus 1 is equal to 0, it means d is equal to minus 1. So your complementary function is here, c1 e raised to minus x. Because there is only one root and it is minus 1. Minus 1 is a real number. And so its complementary function, it contains only one arbitrary constant, because the degree of differential equation is here 1, linear differential equation, and order is also 1. So there is only one arbitrary constant in the complementary function c1, and so complementary function is c1 e raised to minus x. Now how to find the pi? The formula is here, pi is equal to 1 upon phi of d into f of x. Now phi of d is d plus 1. So the formula is 1 upon d plus 1 into function is e raised to 2x into x. Now this is the case 5, e raised to x into v case. So the function v is linear function x. Now using the formula, you solve for exponential function first. Means you replace the term of d by d plus a. The value of a is here 2. The coefficient of exponential function is 2 here. So you replace the term of d by d plus 2 here in phi of d. Phi of d is here d plus 1. So next step, this e raised to 2x as it is. Replace d by d plus 2 plus the remaining term as it is, plus 1 as it is, x as it is. Now simplify this d plus 2 plus 1. So if we solve this bracket term, we have the term, next term, 1 upon d plus 3 into x, and this e raised to 2x as it is. Now the term e raised to 2x as it is. Now solve for v. V is here x, linear function. So you know how to solve for linear function using case 4. Case 4 is x raised to m. F of x is equal to x raised to m. So using that case 4, you can solve this bracket term now. Now you reduce the function d plus 3 in the form of 1 plus d, 1 plus x or 1 minus x, so that we can use the series. I'll discuss it in case 4 or type 4. Now how to reduce the denominator in the form of 1 plus x or 1 minus x? Here the constant term is 3, so you take 3 common. If we take 3 common, the term is 1 by 3 into 1 upon, see, the denominator term. We have taken 3 common, so in place of 3 there is 1, this 1 plus d upon 3. So the term is 1 plus d upon 3 after taking 3 common. This x as it is. Now 1 by 3 is a constant term, so we can write the term as is equal to e raised to 2x upon 3 in bracket. Now the term is 1 upon 1 plus d by 3, d upon 3. So use here the series 1 upon 1 plus x. 1 upon 1 plus x series is 1 minus x plus x square minus x cube and so on. So in place of x there is d by 3. So in place of x you place the value d by 3 only, so that you will get the series 1 minus d by 3 plus d by 3 whole square minus d by 3 whole cube and so on into the function x as it is. Now the function is here x, its degree is 1. So you count the terms up to d only in the bracket, because you know that d means derivative. This capital D means derivative. D means derivative, d square means second derivative, d cube means third derivative and so on. Now the function is here x. So you will get only one derivative of x. Derivative of x with respect to x is 1. Its next derivative is 0 because the degree of x is 1. So you will get only one derivative of x. And so you count the terms up to d only. So the next step is, it is equal to pi is equal to e raised to 2x by 3 as it is. In bracket, you count the terms up to d, means you consider only first two terms, 1 minus d by 3, because from third term you are getting 0. D square by 9, d by 3 whole square means d square by 9. D square means second derivative of x, and it is 0. Third derivative is 0. So you count only first two terms. Now multiply the bracket term by x. So 1 into x is x minus d. D of x means derivative of x is 1. So 1 upon this 3 as it is. So it is x minus 1 by 3. Next remaining terms are zeros. So there are only two non-zero terms. So x minus 1 by 3. And this is your pi. And so the general solution is y is equal to cf plus pi. And so y is equal to, cf is c1 e raised to minus x only, plus pi is e raised to 2x upon 3 bracket x minus 1 by 3. This is the example, first example, e raised to x into v case. Now this is the second example. Solve d square minus 4d into y is equal to e raised to 2x into sine of 5x. Here again, it is the reduced form of LDE. Phi of d into y is equal to f of x. So you equate the function phi of d equal to 0, so that you will get auxiliary equation. So here d square minus 4d is equal to 0 is an AE. Now you take d common. So d common, so remaining term d minus 4 is equal to 0. And so d is equal to 0 and 4. There are two roots, 0 and 4. So both are real numbers and they are distinct, means different. So your complementary function is here. C1 e raised to 0x plus C2 e raised to 4x. So pi is equal to 1 upon phi of d into f of x. Now phi of d is here d square minus 4d into f of x is here e raised to 2x into sine 5x. Now it is again the case of case 5 e raised to x into v case. So again you solve for exponential function first and then you solve for the trigonometric function, means the function v. V is here sine 5x, which is a trigonometric function. So how to solve for exponential function first? Replace the term of d by d plus a. A is the coefficient of exponential function, but here the value of a is 2. So you replace the terms of d by d plus 2. And so your denominator term will be 1 upon d plus 2 whole square minus 4 into bracket d plus 2 into sine 5x, bracket complete. And the e raised to 2x outside the bracket, because its work is over here after replacing d by d plus 2. Again the next step, e raised to 2x as it is. Now expand the denominator term d plus 2 whole square. The expansion of d plus 2 whole square is d square plus 4d plus 4. Again, the next term is 4 into d plus 2. Solve this bracket term so that we will get minus 4d minus 8. Now simplify this term. Next term, e raised to 2x as it is. The denominator simplified term is here d square minus 4, because 4d minus 4d get cancelled. 4 minus 8 is minus 4 into sine 5x. So this is the simplified form. Now the work of exponential function is over. Now you solve for v. V is here sine 5x. Now you know how to solve for trigonometric function sine 5x. You use the case 2 or type 2 when there is trigonometric function. We solve the case or we solve for a trigonometric function. We replace the terms of d square by minus a square. Now here the coefficient of trigonometric function is 5, means the value of a is 5. So you replace the terms of d square by minus 25, because the square of 5 is 25 and you give negative sign to it. And so replace the terms of d square by minus 5. And so the term is here. Here is one correction. The term is here minus 25 minus 4. And so here the term is minus 29. And the term is here is minus 25 minus 4 is equal to minus 29. Sorry. And so the term is here minus 29. So this is your answer. Because we replace here d square replace d square by minus 25. So minus 25 minus 4 minus 29. So here the pi is e raised to 2x upon minus 29 into sine 5x. And so here is again answer is minus 20. Answer is, sorry. So pi is e raised to 2x upon minus 29 into sine 5x, because we have replaced d square by minus 25. It is a trigonometric function. And so the general solution is y is equal to cf plus pi. Cf is here c1 e raised to 0x. E raised to 0x is 1. So you just write here c1 plus c2 e raised to 4x plus e raised to 2x upon minus 29 into sine 5x. So this is one correction here. Next. Next is here. Next example, you take it as a homework. Sorry. So this is your case 5. Case 5 is over here. Thank you. Thank you very much. Thank you, students.